Okay, this is a mini lecture on the right hand rules from chapter 20. Okay, so the first right hand rule is the easiest. This is the right hand rule for the magnetic field around a current carrying wire. So the way you do this one is you simply point your thumb in the direction of the current, and then if you rotate your fingers around, whichever direction they're going, as long as your thumb is pointed in the direction of the current, that will be the direction of the magnetic field. So when the current is flowing upward here, since your hands wrap around the line, the field will be coming towards you on this side, and it will be going away from you on the other. The opposite will be true if the current is flowing downward. If you take your hand and point your thumb down on the page and then curl your fingers around, you see they go into the page here, and if they were to wrap around, they would then your fingers would come out of the page on the other side. So the magnetic field is into the page on this side on the left, and out of the page on this side. Of course, those are lines, so they wrap around. All right. Now, the second two right-hand rules are the ones that have quantitative formula that go along with them. So let's go ahead and write those two. The first is the formula on a wire carrying a current. So the formula is ILB sine of theta, where theta is the angle between the wire carrying the current and the magnetic field. The second one is similar, but it's for a charge traveling with a velocity v. So it's the charge q v b sine of theta. Alright, now in both these cases, let me indicate to you here what the vectors are. So B, the magnetic field, is a vector. We're going to consider the current I to be a vector, and we're going to consider V to be a vector. Now the order in which these come in the equation are important. So I and V always come first. B always comes second. Alright? And then the stuff on the left-hand side are vectors. They're forces, so we'll label those three. So here's how the right-hand rule works. So you take your hand, and you're going to always point your thumb in the direction of the first quantity in the equation. So the first equation has the current. So you'll point your thumb in the direction of the current. Your first finger will then point in the direction of the magnetic field. Now notice that no matter what the angle is between your thumb and your first finger, they define a plane. So this plane, defined by these two fingers, is the same plane as defined if they're in this with this angle between them. So no matter what angle you have between your thumb and your first finger, they define a plane. Now if you take your third finger and you put it so that it is at a right angle to that plane, or normal is the term we use, so it's coming straight out of the plane, that is the resulting vector. Now, as you can see, you're free to rotate your hand so long as you keep your fingers, fixed in orientation. This allows you to move your hand so that your thumb is pointed in a certain direction, your first finger is pointed in a certain direction, and then your middle finger will show you the force that is the resulting vector. Okay, so let's do an example here. Let's do it for the second equation, v and b. So let's assume that particle with velocity v is going this direction. It enters a region of space where there's a magnetic field 30 degrees to that velocity, and let's ask ourselves what direction the resulting force is. So we take our finger, our thumb, point it in the direction of V. We take our first finger, it's in the plane of the page here, so they're both in the horizontal plane. And then our third finger, if we put it at a right angle, is obviously pointed toward the ceiling. So a positive particle entering a region of space with a magnetic field will experience a force upward. Now note that if Q in this equation right here is negative, like an electron, then the force will actually point in the opposite direction. So by our right-hand rule, the force will go up, but the negative sign will ultimately make it go down. All right, I hope that clarifies some rules of the right-hand rule. Now your book does it a little bit more different. What it does is it chooses you take your hand and you put your fingers straight. You point your fingers in the direction of the first vector. So what you would need to do here is point your fingers in the direction V. Then you curl your hand to point in the direction of the second vector, B. And then after you do that, if you allow your thumb to point upward, that's the resulting force vector. It's a little bit trickier because it's not as easy to move your hand in space and do that. I find, if you're a physicist, you find that, making the X, Y, Z coordinate system with your hand, you can pretty much rotate it in any direction and solve any problem. All right? Hope that helps.